Innovations for Defence Excellence, IDEX, launching the 4th edition of Defence India Startup Challenges. Autonomous underwater swarm drones. Naval mines are often positioned in turbulent or murky water to damage or destroy ships and submarines. A decentralized swarm of underwater drones equipped with advanced artificial intelligence and mine detection capabilities is required to reduce the risk and secure the ships and submarines from being damaged by the naval mines. Predictive, Preventive and Prescriptive Machine Health Monitoring System. A modern naval ship is fitted with several equipment and machineries such as radars, desalination systems, pumps, etc. for various in-ship operations. A modular IoT platform with multiple sensors shall be fitted to the naval machinery to continuously monitor their essential parameters. With the help of AI and machine learning, the platform shall be able to predict maintenance in advance, thereby preventing failure. Super resolution for aerial imagery. The sharpness and clarity of aerial images captured by reconnaissance and surveillance aircrafts and satellites are highly affected by sensor capability and atmospheric conditions. Often, the aerial images have low spatial resolution, making it difficult to identify patterns and objects in the image. There is a need to develop an algorithm which enhances the spatial resolution, capable of working on aerial images of various resolutions, optical band and illumination conditions obtained from different sensors. AI-based satellite image analysis. Traditionally, the images from satellites are analyzed manually, making it impractical to accurately identify surface and aerial objects. With advanced AI-based automated image processing and classification methods, the images from the satellites need to be processed in real time for identification of troops, targets, and various surface patterns. Prediction and forecasting of atmospheric visibility. Flight routes and associated operations are planned based on environmental visibility. The conventional visibility forecasting is an inherently manual system with limited accuracy due to human interpretation. It is proposed to develop an automated tool using artificial intelligence for accurate prediction of real-time and location-specific visibility forecast. Computer-generated targets for virtual training. The weapons, avionics and other equipment for air combat in modern fighter aircrafts are rapidly evolving. The pilot training tools and methods used by the armed forces require continuous upgrades to keep pace with the technology. There is a need to develop computer-generated target flights in flight simulators. The virtual targets learn from past flight data and are capable of making real-time in-flight decisions to train the pilots for more realistic air combat scenarios. Real-time health monitoring of air crew. Fighter pilots and flight crew must be in optimal health and fitness to handle the physical demand of modern aerial operations and warfare. In modern fighter jets flying at high altitude, the flight crew is subjected to extreme G-forces and have reduced oxygen. It is essential to measure and monitor the critical vital parameters of the air crew in real time and alert in case of acute and abnormal deviations. MFTDMA-based wideband SATCOM modem. In the battlefield, Communication satellites play an important role in transferring critical battlefront and reconnaissance data. Traditional communications through satellites are slow and inefficient, making it impractical to transfer large data. The need of the hour is a next-generation satellite communication modem with high data rate catering to the seamless transmission of large data, voice and video transmissions. Foliage penetration radar. The soldiers are highly vulnerable to unexpected enemy attacks in densely forested areas, grasslands and swamps. The traditional reconnaissance and target detection techniques fail to identify troops and objects in these dense terrains. The safety and preparedness of the troops can be increased multifold by the development of a foliage penetrating radar, which can be integrated into the night vision and surveillance devices. Reduction of RCS of naval warships. In designing a ship with reduced radar signature, the main concerns are radar beams originating near or slightly above the horizon, as seen from the ship, coming from distant patrol aircraft, other ships or sea-skimming anti-ship missiles with active radar seekers. Reducing the RCS of a naval ship enables its late detection, which is useful for capitalizing on elements of surprise. Target detection in Chaffs environment. Often, air and surface targets deploy Chaffs to confuse the detecting radar systems, which create a required time window for the targets to escape. The deployment of Chaffs also triggers false detection alarms. A primary chaff mitigation solution has to be developed, which reduces false alarms and sustained tracking of targets when Chaffs are deployed. Inviting startups, MSME, individual innovators, research and academic professionals to apply for DISC 4. Selected applicants will get grants up to 1.5 crores, along with the opportunity to co-create and co-develop the defense technologies of future with our armed forces. Besides the grant, selected winners receive product and business acceleration support from IDEX partner incubators, access to defense facilities for QA and certification. Applications are open at idex.gov.in. Innovations for Defense Excellence, IDEX.